Hi, welcome to Dr. Zahir Math. In this video, we are going to study the introduction to reduction of order, finding the second solution. In differential equations, when we have one known solution, one solution already you know, right? If you know one known solution to a second order linear differential equation, we use this reduction of order to find the second solution of the differential equation. This is important. Why second solution we need to find? Because to form the general solution, we need the second solution. Why? What is general solution? Y equals C1 first solution plus C2 second solution. This is what we saw in the previous exercise, right? And keep in your mind, both the solutions are independent solutions. Okay, right. So we explain when they are independent, then only general solutions will form. Otherwise, no. This method is especially useful in when other techniques, for example, method of undetermined coefficients, which we saw in the earlier exercise, how to find the particular solution, how to find the complementary solution, everything we've studied using method of undetermined coefficients. That method will not help you to find the second solution. Okay, and also one more method we study after this exercise, which is called variation of parameters. That method also will not help you to find the second solution. So the only one and only method which gives you the second solution is reduction of order. Okay, where when it helps teacher? Usually it helps solving equations which comes in physics and engineering, sometimes in applied mathematics. Okay, so this is a very important topic, reduction of order, to find the second solution of a differential equation, and both the solutions are linearly independent solutions. Let's start. For this, to find the second solution, we need a formula. The formula is this one: y2 equals y1 integral e power minus integral p dx divided by y1 square into dx. So this is the formula for this question. What is this formula? We are going to find the second solution. Y2 is the second solution. We are going to find the second solution using this formula. So based on this formula, I'm going to give you three important ideas where you people will make mistakes, careless mistakes in the exam. The first mistake is, look at this solution. It's something like e power integral p dx. Have you seen that? We already saw this in somewhere, right? What is that? Somewhere. First order differential equations, linear differential equations, plus py is equal to q. So what is our solution? Y e power integral p dx equals integral q e power integral p dx plus c. Look at the p here. It is positive. It is positive. And here it is negative. This is the first step. You need to be careful. What is that? E power is negative. This is the first step. Okay. What is the second step, teacher? The second step which you need to remember is there is an integral here, and there is a y1 here, and there is a y1 square here. Okay. In the algebra, if you have x square, immediately we will cancel this and your answer is 1 by x. But here the integral is in the middle. Okay, I told you some examples, day-to-day life examples. Integral is in the middle, so you are not supposed to cancel these two things until integration finishes. So make sure no touching, right? Until integration gets over. Until integration gets over. Keep in your mind, until integration gets over. So after the integration is over, then only you are supposed to cancel something. So no touching, that is your second point. And the third important point is, look at this differential equation. This differential equation, P is the coefficient of y. Can you see that? P is nothing but your coefficient of y. P is nothing but what? Your coefficient of y. But look at here. What is the coefficient of y? It is q. So where is P? Your P is coefficient of y dash. So P is your coefficient of y dash, not y. See the comparison. Three things with this. Once again, I'll repeat. Be careful. So the first thing is you need to remember the formula. And the second thing, that is the first thing. And the first thing which you are, first thing for formula you have to remember. But the 3 points which you are going to remember is e power minus integral p. And the second point is no touching between this y1 and this y1 square, no cancellation until your integration gets over. And the third thing is p is nothing but coefficient of y dash, not y. Make sure, okay? Right. See, these all the things you have to keep in your mind. So let's go to the first question. So in problems 1 to 18, the indicated function y1 of x is a solution of the given differential equation. So already they told y1 is a solution. Where is your y1? It is here. y1 is your x e power minus x. This is your y1. Use the reduction of order. Okay, cut this formula 5. This is from the book, right? Use the reduction of order, right, as instructor to find the second solution y2 of x. So you're going to find the second solution y2 of x. Okay, let's start the solution, right? Let us start the solution. Okay, so y double dash plus 2y dash plus y equal to 0. What is the general equation? The general equation is y double dash plus p y dash plus q y equal to 0. For this model, we don't want q. Keep in your mind, we want only p. Look at the rule. Is there any q is here? No, no, no. Only we want p from this. Okay, right. So let us start. Look at the general model. This is the general model of the equation. Y double dash plus p y dash plus q y equal to 0. Right. So you just compare here. P is equal to what? 2. Right. And what's your solution? y1, the first solution given in the question, which is x e power minus x. Let me check again. X e power minus x. Okay, right. So let's go to the formula. So what is the formula? So let us write the formula for finding second solution. So y2 equals, right, y1, right, integral e power minus integral p dx divided by y1 square into dx. This is the formula. Okay, right. So now y2 equals y1. What is your y1? The given solution, which is this one, x e power minus x. So x e power minus x integral e power minus, what is your p value? Which is 2. So p is equal to integral 2 dx divided by y1 square. This is your y1, right? So y and then square into dx. This is the squaring power. Okay, yeah, right. So this equals y2 equals, right, sorry, y2 is not in a perfect manner. Okay, so y2 equals x e power minus x. I'm telling you again here, just make an arrow mark and write don't touch until integration gets over. Okay, right, yes. So integral e power, what is integral 2 dx? Okay, So let me use the same color. Integral, this one is x e power minus x the whole square. Okay, so let's do the integration of this one. E power minus 2 will come out. So what is minus integral 2 dx? Minus 2 will come out, integral dx, so which is minus 2x, so which is minus 2x, okay, into dx. Now this equals y2 equals x e power minus x integral e power minus 2x divided by x to the power of 2 is x square, e power minus x whole square is e power minus 2x, so e power minus 2x. Okay, right. So what happens now? E power minus 2x, e power minus 2x gets cancelled. So this equals y2 equals x e power minus x integral 1 by x square dx. Sorry, 1 by x square into dx, right? So this equals y2 x e power minus x, okay, right? So this is integral x to the power of minus 2 dx. So y2 equals x e power minus x, integration of this is x to the power of minus 2 plus 1 divided by minus 2 plus 1. Because what is the formula for integral x power n dx, which is equal to x power n plus 1 over n plus 1. Plus c is there, but forget it, no problem. So this equals y2 equals x e power minus x bracket open, x to the power of minus 2 plus 1 is minus 1 divided by minus 1. Okay, right. So this equals y2 equals x e power minus x. This minus I'm bringing to the front, which is minus here, and this is x power minus 1. So y2 equals minus x e power minus x. This is 1 over x. X gets cancelled. So y2 equals minus e power minus x is the second solution. Do I need to check whether they are linearly independent? No need to check. Just you find out the second solution, because if you want to write general solution, you need to check. But we are not doing any general solution. Look at the equation. Just look at the question here. There is no word find the general solution. If you are going to find the general solution, then you need to check the Wronskian for these two things. Okay, once again I'll make a hint. Suppose if you are finding general solution, right? Suppose if the question is find the second solution and general solution. Suppose you are going to find general solution, then you need to find the Wronskian. Okay, right? Whether this is linearly independent or not. Right? Linearly independent or not. Otherwise, no. Here we are going to find only the second solution. Right? So let's go to the next question. The same idea, it is coming. So use the reduction of order, right? Cut this formula phi, okay, right? To find the second solution, y2 of x. So this is your y1. So y1 is equal to sine 3x. Okay, first thing. And the second thing, the equation which is given is y double dash plus 9y equal to 0. What is your general equation for this model? For this model, the equation is what? Sorry. For this general model, this is y double dash plus py dash plus qy is equal to 0. This is the model of this equation. So in the formula, we need p. So can you tell me what is the value of p here? This is going here. Keep in your mind, this is y with the q. Is there any y dash is there in this equation? Absolutely no, right? So what is your p? P is equal to 0. But in the exam, you will write p is equal to 9. So p is equal to 0 because the model is coefficient of y dash is p. Okay, right. So let's write the formula for finding the second solution. So let us find the second solution. Okay, let us find the second solution. What is the formula for finding the second solution? Which is y2 equals y1. Okay, right. Integral e power minus integral p dx, okay, divide by y1 square into dx. After that, one important point is there, no touching until integration gets over. See here, after the integration finish only, I cut this x. Did you see that? I cut the x after integration finish. Before that, I'm not touching. You see here, I didn't touch anything. Only I started touching after the integration is over. Okay, right. So let's go and do this solution for this one, which is equal to y1. How much? Y1 is sine 3x. Y1 is sine 3x. So which is sine 3x multiply, sorry, not multiply, integral e power minus integral 0 dx. Your p is 0 divided by y1 square sine 3x the whole square into dx. So this equals sine 3x, okay, integral. Let's come to this point. What is integral 1 dx, which is x? What is integral 0 dx, which is 0? Keep in your mind. So integral 0 dx is 0. So e power 0, after that e power negative 0 is 1. So you are going to get 1 divided by sine square 3x into dx. Right. So this equals sine 3x. Now your mind goes, teacher, can I cancel this and this? No, no, no. See here, integration is there. So no touching. Keep in your mind. Okay. So this one, this. So no touching. Right. So this is equal to sine 3x. Okay. Integral of sines 1 by sine square, I am writing as cosecant square 3x into dx. Okay. Right. But now the formula for cosecant square 3x you have to remember. Okay. So I gave you in the last page in cosecant square x integration. The formula is minus cot x. Okay. That's why I didn't give in the beginning of the page. Maybe you will think the formula will be given in the question. No. So what is the formula? Integral cosecant square x is equal to negative cot x. Okay. Integral of cosecant square is what? Negative cot x. Now our situation is integral of cosecant square 3x. So what is integral of cosecant square 3x is negative cot 3x. For the integration we divide by 3. Okay. So this equals, which is negative cot 3x divided by 3. Okay. Right, this equals, right, so this minus this 1 by 3 I will take it out. So this is sine 3x and then cot 3x, cotan or cot, no problem, cotangent, right. So this equals minus 1 by 3 sine 3x. Okay, this cot of x we can write cot theta is equal to cos theta divided by sine theta. 002 you studied this rule. So this will be cos 3x divided by sine 3x. Okay, right. Now integration is there. It is gone, right? So you can touch now, right? Integration already finished here, right? Integration finished here, right? So from this step to integration done. So now no integration. So okay, so we can touch sine 3x gets cancelled. So which is equal to minus 1 by 3 sine 3x is the second solution for this one. Suppose if they ask general solution, you have to write y equals C1 first solution plus C2 second solution. Okay, right. But provided you are Wronskian, okay, you need to find Wronskian and make sure it is linearly independent or not. So mostly it is independent, linearly independent, but still you should make sure. Okay, right. So this finishes your 4.2, right? Yes. Thank you for watching. Have a good day. Take care. Bye bye.